This is part 2 of the video that helps review for the series test number 1 in BC Calculus. We're dealing with alternating series now. The rule for alternating series is that if you ignore the part that makes it alternating, usually negative 1 to the n or negative 1 to the n plus 1, and take the limit, and you get a 0, it converges. If you get anything else, it diverges. So for example, in this first one, where we have negative 1 to the n over n, we can ignore the negative 1 to the n and just write 1 over n. And if we take the limit of this, it'll help us find the answer. So the limit of this would be 0 because the bottom's going to infinity. And since we get 0, it converges. Now in number 2, we can just ignore the negative 1 to the n. We can write this then as 4 over 6n plus 3. This one is also going to 0 because the bottom's going to infinity and the top is not. So this one also converges. Just to stick with the same kind of problem, let's skip down to number 4. We'll have the limit as n approaches infinity of, ignore the negative 1 to the n over 3n minus 7. Powers are the same on top and bottom, so we just use the coefficients, which would make this answer 1/3. Now if we get anything other than 0, that means this diverges. So you take the limit. This is a 1n, by the way, not natural log. You take the limit of the part that's not alternating. If you get 0, it converges. You get anything else, it diverges. And number 3 deals with the alternating series remainder theorem. It says, how many terms will it take to approximate the sum with an error less than, so I should say less than, 0.001? Okay, the key is that we want to look for the first term that goes below 0.001. And then we use every term before that one. Because whatever term we don't use, the very first one, that gives us our error bound. So I already have this one plugged in, negative 1 to the n over 2x plus 1, ny1. Make sure you put parentheses around the denominator. So now as we go to the table, okay, well you can see here it's going to actually require some pretty big numbers, because 100 is still not quite there yet. So let's jump up to 200, see if that's big enough. Okay, we're not there yet. Let's try 300. I'm looking for something under 0.001. Alright, I'm getting closer. Let's try 400. Okay, 500. Okay, so it's somewhere around 500 it looked like. Remember, if you highlight this, you can see it down below. So I've gone below it. So let's back up and try like 490. Okay, getting closer, 495. Okay, I'm getting closer. Let me just plug in 495 through 500 because we know it's somewhere in that range. Okay, now these all actually say 0.001, so we need to be really careful and actually highlight these numbers so it shows us the exact value at the bottom. So at 495, keep in mind we're looking at the absolute value here, so we don't care if it's positive or negative. We're still a little over 0.001. Still over it, still over it, still above it, still above it. Okay, that's where it changes. So 500 is the cutoff point. 500 we don't want to use because it's below 0.001, but we want to use everything that comes before that. So if you look back here, we're starting at 1, and we want to go from 1 all the way down to 499. So number 3 will be 499 terms to make that work. Now let's look at this second, or this number 5, the second one like it. Now I actually already had this plugged in y2, so I'm just going to delete y1, and I'm going to highlight the equal sign, hit enter. That way it actually uses that function. Okay, so these are way too big. So let's back up and like try 5, okay, 10, 20, 50. Okay, so it's somewhere between 20 and 50. So let's go back up and try 30, 40, 45, 46. Okay, so we know it's after that, so I'm going to start back at the beginning. So 46, 47, 48, 49, 50. Okay, so go back up, highlight these. This is still above 0.001. This one's still above 0.001. This one is not. As soon as you see e to the negative 4, you're below it. So at 48, that's our cutoff. We don't want to use 48. We want to use everything that comes before that. Now this one starts at 0. So we're doing 0 all the way through 47. So 0 through 47 is actually 48 terms. It'll take 48 terms to approximate that with an error of less than 1/1000th. Okay, finally, the anything goes section. Number 1 says, which of the following series converge? Okay, well this first one, A, is a p-series. The power is less than 1, so that diverges. B is geometric. The r right here is greater than 1, so that also diverges. C is another p-series where the power is 1, so that diverges. So our answer has to be D. It's a p-series, that's 3/2 right there. The power is bigger than 1, so it converges. That's our answer. Number 2, which of the following converge? Okay, A is a p-series. The power right here is E. E is bigger than 1, so this converges, and this is our answer. I want to go ahead and look at the others just for practice. B is a p-series. This power would be 1/4. That's less than 1, so it diverges. C is alternating, so it's going to diverge because if you ignore this part and take the limit, you're going to get 5, which is not 0, so that diverges. I shortcutted that a little bit, but it worked. D, we have geometric. The r is greater than 1 as far as absolute value. That's what matters. So it also diverges. Okay, number 3, which of the following diverge? Well, the first one is a p-series where the power is greater than 1, so that one converges, but they want me to find the one that diverges, so this is not the one I want. B is a telescoping series, so it converges automatically. That's not the one we want. I'm going to skip it and go to D. D is geometric, where the r would be 1/3, so that's also converging. So that leaves us only with C. If you ignore the -1 part, you'd actually have 7 plus 1 is how this would work. But when you take the limit of that, you would get 8. 8 is not 0, so this one does diverge. So C is the one that diverges. Number 4, which of the following diverge? Okay, part A, that's p-series, power bigger than 1, so that converges. B, this is geometric with a r less than 1, so that converges. C, well, if we do the nth term test, we get 0, so it's actually inconclusive, and we don't know. So this one, I kind of just have to put a question mark by. Well, let's look at D. D, if I do the nth term test, I take the limit, I get 2/5. And we know by the nth term test that anything not 0 diverges, so this has to be our answer. Even if we don't know what C does, we know D diverges, and that's what we were looking for. Okay, finally number 5. What is the sum of the following series? This is going to be a telescoping series. We can do this by factoring 1 and 3, multiply to 3 and add up to 4, and then using partial fractions. So this can be split up as a over n plus 1 plus b over n plus 3. Multiply everything by the common denominator, you get 1 equals a times n plus 3 plus b times n plus 1. One of the convenient values you can plug in is -3, so you get 1 equals a times 0 plus b times -2. So that cancels out. Divide both sides by -2, you get b equals -1/2. The other convenient value would be -1, so 1 equals a times 2 plus b times 0. So that cancels out. Divide both sides by 2, you get a equals 1/2. So this series that we started with can be rewritten as 1/2 over n plus 1 minus 1/2 over n plus 3. So to find the sum, we're going to need to expand this until we figure out what cancels out and what doesn't. So as I plug in 1, I get 1/2 over 2 minus 1/2 over 4. Plus, now I plug in 2, 1/2 over 3 minus 1/2 over 5. Plus, now I plug in 3, 1/2 over 4 minus 1/2 over 6. Plus, now I plug in 4, 1/2 over 5 minus 1/2 over 7. Now we plug in 5, 1/2 over 6 minus 1/2 over 8. And I think that's far enough. Because remember, the way these work, as soon as one term in the front, calling these the front and these the back, as soon as one front term cancels, they will all cancel out. And all the back terms always cancel out. So 1/2 over 4 right here, negative, cancels out with a positive 1 right here. Negative 1/2 over 5, positive 1/2 over 5. Negative 1/2 over 6, positive 1/2 over 6. So actually, as soon as I see this one right here, this front term canceling out, I know everything after that is going to cancel out. And these back terms right here always cancel out anyway. So the only two terms I have left are 1/2 over 2 plus 1/2 over 3. So that's 1/2 over 2 plus 1/2 over 3. That's 1/4 plus 1/6. 1 over 4 plus 1 over 6. We get that, which I think is 5/12. It is. 5/12 is our final answer. That is the sum of this series.